Welcome to SciTrends. I'm Eva Snyder. Okay, so I love tinkering with electronics and hardware. Kind of like this robotic arm. It's a lot of fun to use. But the more I've worked with it, the more I've realized its limits. Here's what I mean. I can pick up this card just fine. But when my robot tries to do it, it really struggles. So how do you make a machine that can grab things like a human can? Well, we talked with a company who's trying to solve that problem. iRobot, the folks that make the Roomba. They're building way more than just robot vacuum cleaners. Hi, I'm Eva.
Hi, I'm Chris. Welcome to iRobot.
It's nice to meet you. Engineer Chris Jones, the company's senior principal investigator, showed me some of their prototypes.
As you can see, it's a very early robot built by our founder.
Chris and his team of researchers make robots that use a lot of different ways to get around. Some walk on 6 legs like an ant. Others climb walls with suction cups. And some use tank treads to get over rocks and rubble. So moving from place to place? No problem. But when it comes to picking things up, that's more tricky. Most of these robots use a simple electromechanical device to do that. It's a metal claw called a gripper. So what's this?
Eva, this is the PackBot. This is a pretty simple two-fingered gripper, two-fingered pincer. The fingers can open and close, and the fingers can twist around.
A gripper can do a lot of different things in the field, like grab heavy objects, turn them over, drag them around. But with just 2 fingers, it can't do everything.
You need a robot that has a much more capable hand to do increasingly complex tasks, from grabbing and opening doorknobs or doors to picking up a glass of water off the table. Back in the lab, we're working on next generation hands with better capabilities, much more powerful hands. You want to go check it out?
Yeah, I'd love to. Back here, technicians, scientists, and engineers like Mark Claffey are creating all sorts of new robotic parts and writing software that controls them. Hey, Mark.
Hey, Eva.
What you got here?
So this is the Dexter hand. It's a new hand we've developed here at iRobot that can grasp things very similarly to the way a human can.
Mark designed Dexter's fingers to move independently, like ours. But its real advantage? Instead of being made from hard metal, Dexter's fingers are soft and flexible.
So as you can see, these fingers, they have rubber pads here on the fingers, and they have this rubber flexure joint at the end, so this lets the finger twist.
Flexible fingers may not seem like a big deal, but they can help a robot grab different objects.
And close the fingers. Right, so it tries to drive, and we get a stable grasp of the rock. Pick it up, turn it. I'm not doing anything smart about where I'm putting it, right? I'm just closing the fingers, and we get good grasp. If you look at the fingers, they've bent. The rubber just lets the things flex to wherever they need to be to get the best grasp on the object.
That flexibility is what engineers call compliance. It means that instead of being totally rigid, the robot gives a little when you touch it. In that way, Dexter was designed to be like us. Think about it. Your fingers aren't made of metal. They're soft and squishy. When you pick up an object, the pads on your fingertips squeeze around it.
Your hands are also soft in a different way in that they can twist and bend when they're interacting in the real world, when you're trying to pick something up.
The same goes for Dexter. Its soft fingers can squish around an object for a solid grip. And, just like our fingers, they're held in place there by powerful tendons. In a human hand, tendons act like control cables, running from your fingertips through your palm to muscles in your forearm. When you want to close your hand, signals from your brain tell the muscles to contract and pull on the tendons, which pull on your fingers, closing your hand. Dexter works in a similar way.
Right. So each of these 4 motors pulls on one of these tendons. And when you pull on that tendon, it closes the finger. You can give it a try.
Can I try? Oh, it's really hard to pull.
Yeah, so each one of these very small motors can pull that tendon with 60 pounds of force.
Wow. A lot harder than I can do it.
Yeah.
This combination of tendons and flexible fingers lets Dexter pick up objects of all different shapes and sizes, from big ones to tiny ones. But with all those motors and electronics inside, it can be complicated to build. That's why engineers like Ann and Mozika are working on a hand that's a little simpler. So simple, it's filled with nothing but air.
So this is cool. Check this out. It's a full inflatable hand and arm.
That's awesome.
So the fingers are driven by these tendons that run down to the base here, just like you saw on the other hand. And similar to your wrist, this has a wrist that's also driven by tendon cables. We can pull on the tendons to close the fingers.
So cool.
Basically, it's just a glove with a liner inside it. This is actually literally based off a spacesuit glove design. We work with the company that develops those. And inside is the actual inflatable part. So it's basically a balloon. And it keeps all the air inside the glove. And driving all those tendons are these motors with the cable coming off.
So why inflatable?
Well, inflatables are cheap. They're basically fabric sewn together. We add some motors to it, some tendons, and that lets us move everything. This was created on a sewing machine, and some motors were put on it. Doesn't get much simpler than that.
And since the hand is inflatable, the grip is easy to adjust. Add more air for a firm grasp, or let air out for a soft, compliant one. In the future, inflatable hands, and hands like Dexter, could let robots pick up almost any object. So the dream of a personal robot assistant might not be so far off after all. For SciTrends, I'm Eva Snyder.